Good afternoon to my dear classmate and Miss Hanis. And today our group, which is Team 6-7, will present the sliding filament theory, which is the most important part in our muscle contraction. In order to explain our muscle contraction, the mechanism of it. Okay, then we move on. Okay, here is before we start our mechanism today, I would like to share with you the fun fact.
Wow.
The theory was discovered by two scientists with the same last name in 1954. And although in our bio notes, that Hesliu and Hansen was working with her E. Hesliu. How awesome is that? Yeah, you can see here. The three scientists that discovered the mechanism of the sliding filament theory. Next. Okay, actually, how does the muscle contract? Okay, before we dig into this topic, we must know the structures of this filament, also the thin filament and thick filament. So as we know, the thick filament is myosin, and however, the thin filament, it can be said that is the thin filament is the actin, yeah, actin filament. Okay, here we can see the muscle contract when the actin and myosin slide past each other. Okay, it is very simple for us to understand. It means that when the muscle contract, actin and myosin, it will move together. How? And then we see actin filament move inwards toward the center of sarcomere. Sarcomere is the repeating unit of microfiber of the muscle. Okay, and when the muscle contract, I-band and H zone decrease in length. Okay. Which in short, it becomes shorter. Here. Okay, the mechanism of muscle contraction. Action potential that propagate along the plasma membrane trigger the voltage gathered Ca to plus open. Sorry. Here actually the air is molecule, calcium ion. Okay. Calcium is very important for our muscle contraction. Without the calcium ion, our muscle will be cramped. Yeah, and that's why we always say that when the muscle cramp, means that we are lack of calcium ion. And then here, calcium will release into the sarcoplasm to bind to the troponin complex, changing its conformation. Then tropomyosin from myosin side are pushed away, and myosin binding side on actin exposed. Here. As you can see here, there is a complete cycle of the sliding filament theory about the mechanism of muscle contraction. How our muscle contract? Actually, it has its cycle. Okay. Here, I would like to highlight the ATP, which is adenosine triphosphate. Is very important for our muscle contraction as it supplies the energy in order to contract our muscle so that we can produce the movement. Okay, so the first step is ATP is bonded to myosin head and is in low energy configuration. Before it bounded to the ATP, actually the myosin head is in low energy configuration. So it needs the energy And next, each myosin head contains ATPase. ATPase here is the enzyme. As we know, the enzyme always catalyze the reaction. So for here, same goes as ATPase. ATPase here catalyze hydrolysis of ATP to ADP and inorganic phosphate, which is PI. Here. And the second, myosin head in high energy configuration. Okay, now it becomes the high energy configurations because what? Because the ATP supply the energy to it, and yeah, as you can see here, the ATP now is being hydrolyzed into ADP and inorganic phosphate. So we can say myosin head now is very is very high in energy configuration. And you can see here the myosin head, it becomes erect already. Just now we can see the myosin head is bent 45 angle degree. Yes, it bent like 45 angle degree because what? Because it's in low energy configuration. Okay, so then myosin head bind to expose myosin binding site on actin filament. Okay, actually the thin filament here, it has the myosin binding site, which enable the myosin head to bind to it in order to create a cross bridge. Okay, so the cross bridge here is very important, and we will see. Okay, here the third step. Okay, ATP and inorganic phosphate released from myosin head. Okay, after we have used the ATP, ATP will form ATP and inorganic phosphate, which we don't use it. So ini macam sampah sisa kami tidak guna. So we need to throw it away. Then myosin head return to low energy configuration. Okay, so because now it doesn't have ATP bounded to the myosin head, so we can say that it is in energy configuration now. Okay, myosin head then bend 45 angle degree. Okay, 45 angle degree to create a power stroke that pull actin filament to inwards towards center of sarcomere. Okay, here actually has inwards. Okay, and H zone and I zone will become shorter, which is decreased in length. Okay, H zone and I band here, you can simply relate it to your bicep muscle lah. When you contract your bicep muscle, it becomes bigger and shorter, right? So same goes as here is the contraction. When you contract your muscle must be shortened. Okay, the fourth step. After the process complete, myosin head bound to another ATP molecule. Myosin head detached from ATP. Cross bridge block and new cycle begin. As you can see here, the ATP bounded again to the myosin head to break the cross bridge and to enable the cycle to begin again, to ensure the complete cycle. Okay, here's from us. Thank you for watching our presentation here. Okay.